Okay, guys, so we're actually going to start the complete the square lesson. Now, that's all we're working on for this entire section, but I'm breaking it down into 5 levels that start out pretty easy and go to very messy. So before we get started, I want you to pause this video and I want you to write these bullet points down. They take place, and this is the basic, most necessary information that you need to get started. Now that we're back, after you wrote down these bullet points, I actually want to go ahead and start working on some problems with you. So I plan to do 2 as notes, and you'll do 1 as practice. Here's our first example. Again, this is our easy type, and this is just so that we can get our feet wet and following the rules that I put up here. So the first example is x squared minus 10x minus 1575 equals 0. So this is a quadratic in standard form. But what we need when we're completing the square is the first thing we have to do is get the constant on the other side of equals. So I'm going to add that 1,575 over. I'm adding it because I need inverse operations, and that gets it in the correct format. So this is ready to complete the square. After I do that, I'm going to locate my b term. Now my b term is negative 10. And what I'm going to do over here on the side is I'm going to take half of negative 10. And I do that just by dividing by 2. And I'm going to keep this number. So I'm writing this down on the side, and I'm going to keep this number, okay? Because that number is going to come out to be very important to us in about 2 minutes. After I take half of negative 10 and get negative 5, I'm going to square it. Well, negative 5 times negative 5 is positive 25. And I'm going to add that to both sides of my equals. Again, I got the 25 by taking half of negative 10 and squaring it. Negative 5 times negative 5 is positive 25. And you add that to both sides of equals. See, I can do that because it maintains equivalency. The next thing that I'm going to do is I'm going to clean up the right side, and I'm going to write this as a factor. Now, I want you to realize something. When we do this trinomial factoring, what I want you to see is that this is always going to be a square. That's the whole purpose. Complete the square means to get a square. And what we use is this value right here. The half of b, that's what goes here. So this is going to end up being x minus 5 quantity squared. And if I multiply that all out, I'm going to end up getting this trinomial that's right above it. So the reason why I wanted you to write it down over here is because we need it. It's real easy to kind of take it, write it down, and then use it. On this side, I've got 1575 plus 25, which is 1600. Okay, so now that we have completed the square, literally made the square happen, what we need to do is we're going to use the square root method to solve. Miss Meek talked to us about that in lesson 1.7. So we're going to take the square root of both sides of equals. And when we do that, there's a couple things you need to remember. Of course, when you take the square root of a square, they're inverse operations, so they cancel. But when you take the square root of a number or any term, you really get the plus or minus value of that number. So the square root of 1600 I can actually do, which was why it makes this so easy. The square root of 1600 is 400. So this is x minus 5 equals plus or minus 400. 40, not 400. Good grief. And then what we're going to do is we're going to make sure you have a 40 here, not a 400. And then what you're going to do is you're going to split these up into 2 equations. X minus 5 equals positive 40. And then x minus 5 equals negative 40. And we're going to solve this for x. So I'm going to add 5 over. I'm going to add 5 over. And my roots, my solutions, my zeros, my answers, my x-intercepts are going to be at 45 and at negative 35. So all the stuff I did here in green is what your lesson 1.8 was, and that was your square root method. So the new stuff occurs in the blue section. This is the complete the square method. Once you get it into a square term, that's when you use square root method and finish it off. All right, we're going to do another one. And this time I'm going to know how to take the square root in my head. Okay, here's your second example. Back to blue. X squared minus 6x equals 391. Okay, interesting thing here. This one was already put into ax squared plus bx equals c format. See, the constant's already over here, so we're ready to rock and roll. We're going to take half of the b term. So my b term is negative 6. So I'm going to take half of negative 6 by dividing by 2. That's going to give me negative 3. And then I'm going to square it. Don't forget that the whole purpose of this is to complete the square. So we're going to keep that here. And then when you square that negative 3, you're going to get positive 9. And you're going to add that to both sides of equals. Half of negative 6 is negative 3. And negative 3 times negative 3 is positive 9. That's what you're adding to both sides. Now it's time for me to complete the square. I'm going to rewrite this as a factor. Do you remember what to do? This is like our little shortcut. Whatever you took half of, or whatever value you got for half, that's going to go here. That's that part. Will that always happen? Yes. And 391 plus 9 is 400. Okay? Now that we've completed the square, we're going to go into square root method mode, and we're going to solve this thing. So to solve this, we're going to take the square root of both sides. We're going to end up with x minus 3 equals plus or minus 20. Yes, I did that right. And we're going to split them up into two equations. X minus 3 equals positive 20, and x minus 3 equals negative 20. And then we're going to solve each equation to figure out what the roots are, or the zeros. When I add 3 over here, I get 23. And when I add 3 over here, negative 20 plus 3 is negative 17. So our solutions, our roots, our zeros, our x-intercepts are these two values here. I keep them in braces. That's what the curly brackets are. They're called braces because those are both x values. It's not a coordinate. Those are both x values where these would be the places where our quadratic, our parabola, would cross the x-axis. Okay? Now go ahead and try your problem on the next slide, and then I will be with you in a moment to give you an answer.